Hey, what's going on, folks? It's Mike here, and welcome back to the Programming Language First Impression series, the series in which we take a look at a programming language for the first time for about an hour and just spend some time getting to know that language, learning it from scratch, using the resources that we find, check out the ecosystem for that language, and overall just sort of get a feel for a new programming language if you're looking for one. And while we don't compare and say which language is better than another in this series, we often might compare features or just different ways of doing things. And today the language I want to talk about is one that actually I saw pop up in the comment section a few times throughout this series, and that is going to be the Dart programming language. So Dart is a language which I remember gained a lot of steam from Google originally several years ago at this point, probably 10 plus years ago. So let's go ahead and just learn a little bit about the Wikipedia, and then we'll go ahead and dive into the main programming page here. But it is apparently a programming language that's still alive and well here, where you can paint your UI to life. Okay, so I can't wait to find out what that's about. But let's just get a little bit of the history here so we can orient ourselves to the Dart programming language. Again, I remember there's a lot of excitement. I was in graduate school around this time. So yeah, I remember, 10 plus years ago, so 12 years ago, according to when this, we're in 2024, so 12, 13 years ago at this point, 12 and a half years. But yeah, this was developed by Google. And at the time, Google was kind of doing some interesting stuff here because we know that they have the Dart programming language. They've done a lot of stuff with C++. There's work from folks on Carbon who are involved with Google. There is, of course, Google's Go language, which is one of the first languages that we looked at in this series. So Google themselves has, never been afraid to make languages here and apply them in the ecosystem, which again, it can be a great way if you're a big company to, improve the popularity of a language and actually get some actual use cases. And through that engineering and those use cases, you often can improve the language. So I'm really curious about learning about Dart, as I've actually never tried it. Some of the languages on this series I've played around with before or done some tutorials, but this is one, again, I've truly never written a hello world even in Dart. So let's see. So it's a language designed by Lars Bach and Casper Lund at Google here. Let me go ahead and see Lars. I've seen his name come up a few times here. So let's see. So yeah, he's done some of the work on V8, which is JavaScript, which is probably what a lot of our browsers for a long time have been using, or variations are built on top of that, which is kind of interesting. So good to know some of these folks here who are the designers. Sounds like they've had some interesting careers, working on interesting projects, but I'm assuming since he had a background in JavaScript, that made it make sense to have someone like him, or why he was working on this with Casper for web and mobile apps here. So I'd like to learn a little bit more about the history on that. But again, I've always thought of Dart as a web language, but again, that's because my memory is from 2011 here, but interesting to see mobile apps as well as server and desktop applications. So again, it can be hard for a programming language sometimes to break out of its, what you sort of know it in its mind. Just to give another example, I was thinking of Swift. People think about it as an app language, but it's, a true systems language in the ecosystem. So again, I wonder if Dart has broken free of that stigma in the same way that Swift is breaking out of it now as a general purpose, programming language for desktop, mobile, web, etc. So let's see, Dart as a language, though, let's focus on that, is object-oriented, class-based, and a garbage-collected language. Okay, so it's in the C family here, and it can compile to machine code, JavaScript, or WebAssembly. Okay, cool. So it's got a bunch of different targets, and it's got some features here for interfaces, mixins, abstract classes. Let's see, reification. Let's see here. Let's take a look at that here. I don't know if we've seen that explicitly highlighted in any of these languages, but of course generics and then type inference here. So I wonder if it's a strongly typed language. It says it's using type inference here. So that'll be kind of interesting to look at here. Let's see here. Reification is the process by which abstract idea about a computer program is turned into an explicit data model or other object created. Okay, so yeah, reflective programming languages. Okay. I guess I just hadn't heard that term before. Or I've heard of it and forgotten it. Anyways, let's see. Okay, so Dart was unveiled at the Go2 conferences. Okay, yeah, in Denmark. It said, Lars was Danish, so I wonder if that was the reason for doing it. These Go2 conferences are like developer-based conferences if you haven't seen them. I've seen a lot of quite nice YouTube talks from them as well. I haven't attended, but seem like they're interesting. And it was released, okay, Dart 1.0 in 2013. Okay, so that's about when I realized it, or remember it in my memory. I had some friends at Google working on it, which is cool, and they couldn't tell me what they were working on because it was super secret. But let's see, it had some mixed reception at first. Yeah, and I sort of remember that as well. For fragmenting web, yeah, I guess development. Maybe folks thought, kind of interesting around 2011, right? And this is sort of like peak Web 2.0 time. JavaScript's taking over, and we're kind of wondering if there's, other languages that could fill that space, or if everything's just going to be JavaScript forever. I think now we've seen a lot of, JavaScript is what's powering our browsers, but languages can compile down to JavaScript, as apparently Dart can do here, or WebAssembly, right? So there are some sort of different targets for browsers. So kind of interesting to see the language here. Let's see here. So they had plans to go to Dart VM in Chrome. Okay, so that would have been really interesting. Yeah, if we started writing a lot of our code in Dart, and then Chrome supported that. That might have been actually a really big driver. So that's interesting. Again, maybe some other folks know more of the history, as I wasn't following web too closely around that time here. But I guess they made a decision to change it to JavaScript. Interesting here. Okay, let's learn a little bit more about this. It looks like 2.6, there is a Dart 2 native code here. I wonder if it just compiles down to C or something, or if it is actually going to assembly. That would be interesting. Okay. So yeah, with this extension with 2.6, I think I saw 3.4 is what we're at here, and very, very recent. Okay, so again, this is a language that's being in use today, and it's cross-platform, and it sounds, it's supporting all the platforms that you'd want. So, desktop, server, mobile, web, and so on. And it looks like they got WebAssembly as a target here. Okay, so, it's kind of interesting, again, looking at these paths that different languages change. And this might be an example of one that had to maybe pivot a little bit, right? Either by adding different targets for the language that, maybe or maybe not were intended, but have really increased the lifespan. So I'm really curious about Dart here. It looks like there's a few different implementations here. Okay, so let's take a look here. I think we're just gonna actually just dive in here and see how to start building things here, because a lot of this is about the different, let's see here, things here. Now here's an interesting talk. Let's look at actually these 2 points here: concurrency and null safety. Okay, so they have independent workers that don't share memory, but they use message passing. Okay, so this is like Erlang. Yeah, if you're going to go into like a web language, right? We just looked at Erlang. That was the last language you saw me kind of fumble through and try to learn here in an hour. Because that one, again, Erlang is a language that I've used before, but it is one that you have to, one, it's not a C-style family, so that takes me personally more time to work with. But it does have the actor model and message passing, which I actually really like. But takes some getting used to. So it's interesting to see that Dart uses that process for concurrency. Seen a lot of different successful projects in Erlang with that. Hopefully that we'll also see a few. Obviously there are some in Dart for concurrency in the web that are using it, but I'd be curious to see which applications. And then let's look at the safety, because that's such a big topic in programming languages these days. So they introduced sound null safety. Okay, interesting. So this serves as a guarantee. Yeah, so sometimes when we talk about soundness of a program, that's sort of, can we prove or sort of say something usually about safety? Sometimes it could be about concurrency or something, like how sound or safe a program is. So this is interesting. This is a guarantee that the program cannot return a null value unless it has explicit permission. Okay, so I wonder if there's like annotations in the language or something. So that's kind of neat here. Okay. So let's see here. There's a few different development environments here. Flutter, which I know is a pretty popular tool that Google has introduced. To folks that have worked on it. Yeah, UI software here. So we should take a look at it here. Interesting. Built using Dart, C, C++, and Skia. I haven't heard of that. I'm sorry if I'm pronouncing that wrong. And interestingly, Flutter 2.0. Okay, you can target a bunch of different applications here. Okay, or platforms. So very interesting stuff here. And then let's see, our hello world looks pretty familiar, simple for loop. Okay, so maybe we'll be able to make a little bit of progress here. I've got classes, final variables. Okay, this is looking like a nice language here. Again, all algo stuff, so I usually have it, for better or for worse, I kind of think in C. So anyways, let's go ahead and take a look at Dart here. The language, see how we can get installed. Yeah, we can look at our data, I guess. Let's see. Okay, now that's kind of interesting already seeing this instant hot reload. Again, if this is a compiled language or it's just rebuilding, I actually just did something recently where I coded a hot reload system, and you do that with like dynamic linking as one way to achieve it, I suppose. So it's kind of nice if that's something built into the language and it just refreshes your project. You don't have to keep compiling. I find that's nice for iteration time and for just building more quality code. So an approachable, portable, and productive language for high quality apps on any platform. I like that. Okay. So approachable. Let's make this a little bit bigger here. Consistent, concise, strongly typed. Okay, so that answers our question. This is a strongly typed programming language. An int is always int, those types of things. And then it's got things like null safety and pattern matching. Cool. Okay, so maybe we'll try to get to see that feature here. For productive development, make changes instantly. Use hot reload to see the results instantly on your running app. Love that. Okay, so this is going to be really interesting here. Portable and fast on all platforms. Okay, so ARM, x64, RISC-V even. Okay, that's pretty cool. We haven't talked about architecture or assembly too much. I do have some x86, 64 assembly videos somewhere if you dig deep enough on my YouTube channel. But RISC-V is kind of a really nice open source instruction set, which is really cool. Or compiling to JavaScript and WebAssembly for the web. Okay, so you've got everything basically that you need here. So this is pretty cool here. And they're expanding a little bit more on approachable here. Yeah, this looks like good stuff here. Productive, make changes, do the hot reload, flexible type system. Nice job with this website, by the way. I'm assuming it was written in Dart. This is quite nice here, and fast on all platforms. Okay. So one thing I'm going to be curious about is seeing the ecosystem as far as like libraries and stuff. Yeah, I wonder if we're targeting desktop, do I get access to, I'm assuming I could just like link in C libraries and stuff and get access to all that. If we're attaching to web, I assume I could just, load up any web package or JavaScript like library or framework. Let's see, ahead of time compile. Or I believe that's what AOT is. Let's see. AOT, let's see. Dart, yeah, ahead of time compiler can compile into native ARM or x64. Okay, cool. Yeah, I need to look up this term. Sorry, we're going to look up things as we don't know them. Because this is kind of new stuff that we haven't seen. I believe this is kind of similar to JIT, but let's see here. Ahead of time compilation. And this is some stuff that, again, I used to know, but I just kind of forget things. Let's see, it's the act of compiling an often higher level programming language. Okay, so like Dart, C-based language, to a lower level language. Okay, so that could be like assembly or like a bytecode, I'm assuming. At build time to reduce the amount of work needed to be performed at runtime. Okay, so this is just like, okay, so compiling C or C++ or an intermediate representation, says it's Java bytecode into native sys-dependent machine code. Okay. Okay, so it's often seen as the opposite of just-in-time compiling. Okay. Yeah, okay. I was trying to think if there was anything more to this. Let's see. I guess ahead of time compiling is just compiling to machine code. Okay, fair enough. I thought there was something more to it. Maybe there are some variations of this that I'm thinking of. I guess there's a few different strategies here. Okay. Anyway, we'll learn more about that here. Let's see, target the web, run backend code. I mean, that seems like a real strength here, right? If I can write the web version in Dart, and then I can also write in the same language, hire the same people to also do the backend, like compiled code that's running in my server or whatever, that's kind of nice, right? I have one code base, I can leverage the same ecosystem, tools, programmers, etc. That's really nice. So there's a really strong advantage here, I think, and probably something to pay attention to. If you're starting a company or something, to having a language where you could do the front end and the back end in the same language and have like WebAssembly as a target. I think these are becoming more and more necessary things going forward as you're choosing languages. Okay, try Dart in our browser. Sure, let's run this. Hello. Okay, so this is pretty much like a C program or a D program that we're used to here. Let's see here. Is this some sort of like string interpolation thing where I can just pop in a string and put in the variable? This is the kind of thing, if you've done like shell scripting, a lot of scripting languages and stuff have this, and languages today are starting to get this feature here. Rather than hello, space, single quote, comma, a variable, or plus, and then, converting to a string or something, it's nice to just embed in the string here. It actually looks a little bit nicer here. I like that. Want more practice? Yeah, let's learn the language here. Let's see what else is going on here. I kind of want to, we'll dive into this, and I think we could just do it in the web or even in the examples, which is nice. So we'll see what the setup is here. I kind of want to try and see if we can get a native code and a WebAssembly maybe. Let's check out the community first, see what's going on here. Okay, so they got an X account, a blog, on Medium, I guess, where they're doing Dart language stuff here. And stuff's popping up, relatively frequent. Dart and Google Summer of Code here. I wonder if there's any, Google I/O, I believe, is the big Google conference. Maybe that's where the Dart folks meet. And then, of course, okay, there's Flutter, and looks like some online stuff. Okay, Dart reviews. Okay, cool. This is in the, I wonder, again, if the development's done fully with in like Google, or if this is because I think some languages that started off, for instance, like Go, if I recall, let me go ahead and see, back in our Go programming language, this is open source again, which I know started off as a Google effort. Here, let's go back to Dart. I wonder if Dart is the same here. Okay, anyways, let's take a look at a few things here. I like that, you just have this try Dart here, and I could just start practicing. That's cool. That makes it really easy. I guess it's just taking me to the bottom of this page we were on already. But it's got a bunch of samples here. Oh, it's got a game here. What is this? Let's just play it here. Okay, it's written in Flutter, a few 100 lines of code here. Let's see here. Flame game. Okay. I guess you got to call it something else here. This is Breakout or Arkanoid or whatever you call it. By a few different names here. But okay, that's kind of cool here to see the different graphics. It's just running in the web, which is nice here. I do a lot of graphics apps development in geometry and, of course, computer graphics. So this is kind of nice here to just see that you've got a quick way to just set something up here. This is doing all the Flutter stuff here. I don't see any flames, though. We gotta fix that. All right. Let's check out the samples here. Google AI SDK. Okay, cool. Yeah, AI is all the rage, so we got to see what's going on here. And it looks like just from their imports, okay, you got some packages, Dart-specific ones here. Okay, to use the Gemini. Okay, I don't have this. How fun is the Dart programming language? Let's see. Okay, I didn't register. I'm sure it's very fun. Anyways, okay, let's quit messing around here. Let's see how we get the SDK. Otherwise, we'll do some of the examples in the web browser. Okay, so Dart SDK includes libraries and command line tools you need. So I need to consult this here. On Linux, let's see, x64. Okay, so it supports all these platforms. Let's see here. I got a Docker image. That's great. They could just get started here. And they've detected my Linux setup here. Okay. Let's move this here. And let's install. Okay, so update my package index. Okay, let's Linux GPG QE. Okay, Dart repository. Okay, so let's just do it by their instructions. That's fine. type in my super secret password. Hopefully you didn't see it. And we'll go ahead and get this stuff started here as we find our resources here. Oops. Okay, this won't take too long, I guess. Try to keep my Linux up to date here. That's always a good idea. So let's see. Okay, so they trust my system here with whatever. Let's see here. Just kind of give it a quick look here. Okay, we're gonna add that to our packages to search from our repository, and now we're gonna install Dart. Okay. Okay, then we got the SDK and so on, and how to uninstall. Look at that. A lot of languages I've looked at don't show you how to uninstall it, so that's actually really nice. All right, so good job. Again, not that we're gonna uninstall it, but okay, and they're telling you how the versioning works here and so on. That's actually kind of nice. Just so you know. Yeah, kind of covering all the bases here. So very nice here. So let's see. Do we have it? Dart, I'm assuming. Yeah, here we go. Okay, so first impressions here. Let's see. They're giving us some help here. Dart CLI tool, use Google Analytics. Okay, so telemetry is not set to disable the reporting of telemetry. Okay, sorry, I'm going to disable this because I always disable these things. All right. Let's see what else is here. Okay, so I've opted out. Okay, that's fine here. They told me the first time. Okay, so let's look at the options here. Okay, so I like this. We've got an analyzer, compile. I mean, some of these things are kind of, let's see, do I still have Go on my system? What was it? Golang? I forget what it was. Sorry, my Go folks. But I'm just having a flashback and remembering like these pretty similar ideas of like creating a package, having an analyzer here, which is super cool. Automated fixing, generate documentation, formatting. I really like these things. Like if you're building a modern programming language these days, you pretty much have to have some subset of these things or otherwise tell folks that these things are coming. Because the languages, the new languages that are coming out that have these and resources behind to do these efforts, like a Google or, a big company, folks are getting used to having these. So anyways, it's just nice to see here. Regardless if we get to them. So anyways, let's see here if we could just write a hello world and what that results in. So let's split the window here. Let's do hello.dart void main, and we'll print hello world. Okay, so single quotes here, semicolon language it looks like. In Dart, let's see what happens here. Hello world. Okay, so it's just running it here. Interesting. So I wonder if that compiled it. What happened here? We're just going to run these in here for now, I think. I do want to open up this here. There's got a core library. Okay, so they got core, async stuff, math, HTML for the DOM, and then some multi-platform libraries here. Okay, like your collections and so on. Yeah, I guess this is one of the things, especially in a language where you can target web and desktop. Sometimes your standard library is going to become a little bit, not to say fragmented, but you're going to have to define clearly what parts are available. And they've got here like the native platform libraries. Okay, so like foreign function interface with C libraries. Okay, so that answered one of my questions earlier. Yeah, you get access to all of C. That tends to be the case with any compiled language here. Need to get some I/O stuff, some concurrent programming using isolates. Okay, so independent workers similar to threads. Okay, so I guess that's what they call them. But they're really telling you exactly what they are. They're isolated processes, right? So sort of like the Erlang method here. Okay, so we got our web packages. Oh, this is kind of cool. We got a 3D programming in the browser here with Dart. That's cool. Angle instance arrays. Okay, so they're using the angle library, which I think translates these to like Vulkan calls or something. That could be kind of cool to dive into here. Graphics library. Okay, cool. I wish more programming languages had graphics libraries. Anyways, let's take a look here at some Dart features anyway. So anyways, we got some variables here. Name, Mike. Sorry, I'm not going to do the Star Trek one. And let's see here. year. Okay, so this is where you get the nice type inference here. I guess this is just, going to tell us here, 2024. We'll know what the type is here, which is kind of nice here. Interestingly here, let's see. So we got, I wonder, let's see, is this a list here? We'll have to find out here. And then is this like is it a dictionary? Is it a JSON? Like, let's see here. Because you'd want like a JSON type thing in a web language. Let's see. Planets. Again, I'm just going to switch things up here just a little bit. Earth, Mars, Jupiter. Okay, there's a few that kind of come in order here. What if I just do print planets? Will it print out the list there? It does. Nice. Nice. Or actually, sorry, we don't know if this is a list or a dynamic array or what this structure is, so we'll find out soon here. But let's get a few of these here. Image. Okay, and we got our tags. Okay, then I got Saturn. I mean, this is matching pretty much exactly what a JSON looking file thing is, but again, we got to find out if this is a dictionary. Path to saturn.jpg. Okay, just so we have something in there. That compiles. Perfect. I haven't made any mess ups yet, so that's good. Control flow. Okay, so this looks basically the same as in like every C library here. Okay, read more about variables, default values. I do want to read more about this actually, so let's get rid of that here. Okay, so initializing it, does it have, let's see, variables store references. The variable name contains a reference to a string object with a value of Bob. Okay, so reference language. A lot of new languages that we're seeing and some old languages are leaning more into value semantics here, so that's kind of interesting. So let's see what they mean by that. The type of the name variable is inferred to be string. Okay, that's where the type inference comes from. That's great. You can change a type by specifying it if an object isn't restricted to a single type. Specify the object type or dynamic if necessary. Okay, so that sort of makes sense here. Because in the web module, or web world, I should say, right, when you have JavaScript, you can change the types and so on. So I guess you can say this. And I'm assuming, again, this is a strongly typed language, but you could probably do, funny things like use this dynamic, which looks like something that can maybe take on different types, or maybe it's a variant or something. Let's see. So again, explicitly declaring things. Okay. This page follows the style guide recommendation of var. Okay, there is a style guide here, which is good. Google has their style guides, which is good. I like this for a language. Again, it teaches me effective Dart design, and then you sort of know what good code is. It's nice to have this. Again, you can tell this is a production language, a language that's used in real engineering stuff, which is cool. Null safety. Okay, so again, we read a little bit about this as one of the selling features for safety, which is great. Let's see. Null safety presents an error that results from an unintentional access of variables set to null. The error is called null dereference error. So that's cool. So there is some proving thing, or it says the Dart compiler detects these potential errors at compile time. Okay, so they are doing some control flow analysis here to make sure that everything's assigned or has a value. Okay, neat. Okay. Okay, so like in other languages though, let's see. Dart's compiler prohibits, okay, so some of these scenarios. Null safety introduces 3 key changes. Okay, since we're reading a little bit more, let's make this a little bit bigger. When you specify a type for a variable or another relevant component, you can control whether the type allows null. To enable nullability, you add the question mark to the end of the type declaration. Okay, so I've seen this a few other places. So this can be null or a string. And a reason, you might use this, some folks, if this string, for instance, in another language was allocating memory, it should be possible that you get a null value back, and then you can check that, right? If you have a pointer, right, and it returns null, then you know that that's sort of like an error code or it didn't return properly. So you can kind of handle that case. So there's reasons to allow your variables to become null. So for the string, on the other hand, that's a non-nullable type. Okay. So yeah, that's kind of nice. Again, another feature of modern languages that you'll see. A lot of languages, even if you don't have this feature, you could often wrap a type with like your own nullable. I think that in D, although I don't use it too much, has this type of thing here. So again, you're just wrapping the type, which is fine. Let's see. Otherwise, you must initialize variables before using them. Nullable variables default to null, so they're initialized by default. Okay. Otherwise, Dart doesn't set initial values to non-nullable types. So I like that. I like initializing my variables. It's usually the right thing to do, with the exception of if you have a nullable type here and you want to allocate like some giant buffer of memory, it doesn't make sense to zero initialize it for performance reasons. So you would just have that null. So as long as I can do that, that's okay. Okay, so that kind of answers my question on like the idea of, do we have to initialize variables? So that answers that question. Let's kind of peek around here. The late modifier has two use cases. Something that's initialized after its declaration. Oh, okay. So that answers that question about like, hey, maybe this is something that's going to be a really big buffer or something, but I'm allowing myself to, lazily initialize that variable. That's kind of cool. Okay. That's neat here. So you can fix the error by making it late. If you're unsure the variable isn't is set before it's used, but Dart disagrees, you can fix that by marking it as late. Okay, that's cool. If you fail to initialize a late variable, and runtime error occurs when the variable is used, though. Okay, fair enough. Right, so here it is, non-nullable type. We don't initialize it because we don't know. Maybe we're reading it in from like some config file or something, or a mixin or something, and then we assign it down here. Okay. So the initializer runs the first time the variable is used. This lazy initialization is handy in a couple of cases. Variable might not be needed, and as initializing it is costly. You're initializing an instance variable, and its initializer needs access to this. That's pretty cool here. So yeah, of neat ideas that I don't think we've seen yet, at least in like sort of the early tutorials. A lot of languages I think have these sort of different ideas, or they're not too hard to program yourself, right? You could have like a again, wrap a type and check if it's initialized or something later, or, there's a couple different strategies, but I think this is the first language we've looked at in this series that has a late sort of thing. D has lazy as a keyword that you can do. So it's certainly a similar idea here. I kind of like the name, late, but I think lazy is probably even a better term because it describes the computer science like term you would look up. But I think late, again, is clear. So either of those. Final and const. Let's see. If you never intend to change a variable, use final or const. Okay, so we sort of know those things. Const correctness. And a final variable can only be set once. Okay, so interesting. Const variable is compile time constant. Okay, I wonder what the, we talk about on programming languages, the compile time situation is with Dart as far as execution. But alas, let's go ahead and keep moving on here. Let's take a look at functions here. Now for functions, they do recommend you specify the types. That's how I'd write them anyways. Let's go ahead and write this Fibonacci here. Should look basically exactly the same as we would do it in C, but they are showing off we have recursion available here, short circuiting. Again, I write my functions just a little bit more with more spaces, and we can return the Fibonacci n-1, that's Fibonacci n-2. All right, let's compute the 20th Fibonacci number. Why not? Let's just print it out here. Fibonacci 20. Just to again mix around some different things here. There it is. I'll take it for what it is. All right. Okay, now cool. This is cool. Shorthand arrow syntax is handy for functions that contain a single statement. Again, we have something like this in D. And again, I bring up D or C++ because those are the two languages that I know the most. This syntax is useful, let's see, when passing anonymous functions as arguments. Okay, cool. Let's take a look at this here. Let's just copy this one here, because already I'm seeing a bunch of things that I like here. Okay, I don't know what flyby objects is, but maybe let's look at this. Is it, I'm assuming that comments things out. Yes, okay. Flyby objects.where, okay. And then this is the lambda or the anonymous function here. Yeah, they call them anonymous functions here. And then I can do dot for each on it. Cool. Now I don't know yet if this is, some languages have universal function call syntax where you could just kind of do dot and then chain as a result here, which is nice. But I don't know if for each is also like part of the algorithm library that takes in like a range or something. But anyways, that's kind of neat. Read more about functions. Okay, let's just kind of dive in here. We've got our named arguments. You can omit the types. That's kind of cool. Again, I think that's just giving some flexibility probably to when you're supporting multiple platforms, especially since when you're supporting web and like native and, you know, mobile and stuff, you really do have to have a good type inference system, I suppose. So kind of neat that you don't need the types, but again, I would probably put them in for clarity and get type checking. And again, they've got, the shorthand syntax for these one-liners. Which tend to be, again, these types of things, these, like this is a test here, or maybe a predicate function, are useful to, you know, have in a language for, especially if you're passing functions in as parameters to other functions, right? That's kind of nice here. So the arrow syntax, okay, that's what the equals and the greater than sign are for. Okay, parameters, I'm gonna name the parameters. Let's see here if there's anything interesting. That's kind of new. Required. What's this? If you instead want a name parameter to be mandatory, requiring callers to provide a value for the parameter, annotate them with required. Interesting. Okay. So I wonder if this is a way that allows me, right? Okay, so I could provide default values, but if I must have something, required is what's passed in here. Interesting. Because I wonder if can I call scroll bar and only like pass in one argument or something? That'd be kind of interesting here. But that's something that's new here. And required things could still be nullable. Okay, fair enough. I wonder if nullable is one of those things when you start thinking about it, it just starts appearing everywhere in your language. Maybe an interesting question for a language designer to think about. Let's see, positional arguments. Dart allows named arguments to place anywhere in the argument name, whatever suits you. Okay, so you get some flexibility as far as how you're putting these in sort of the order. So yeah, interesting language here. Let's see, optional positional parameters. What is this? Wrapping a set of function parameters in brackets marks them as optional positional parameters. If you don't provide a default value, their type must be nullable, as their default value will be null. Okay, so nullable is you can pass in with the brackets here. Let's see the example without Bob says howdy. Okay, because you pass in from and the message. Okay, and this would just be null here. Here's an example calling the function with a third parameter. Okay, so I guess it's just a way to, again, have the optional. I mean, what this ends up saving you from is probably having a million different overloads of this different type and repeating your code. So again, that seems reasonable. Let's see, with a device here. Okay, interesting. Anyways, so anyways, that's kind of neat here. It's kind of interesting. You know, when I think about this type of thing too, I wonder if it's good or bad, but I guess this is a way too that you can, with functions, let's say you have a code base that lives a really long time, and you do change like the behavior of this, and you want to like add other parameters or something without creating a new function. I guess you could just have a bunch of nullable or optional parameters that change the behavior again to kind of keep things consistent. So again, it's kind of interesting style here. Okay, we know about the main function, which is the start. We can get a list of arguments. Okay, so we're seeing some of the built-in types here. That's neat. Functions as first-class objects. So again, I could pass a function as a parameter to another function. Perfect. Okay. Let's actually type out this example here because this is kind of interesting as far as just getting a feel for the language here. And let's do it with void print element. Okay, int. element. Okay. Oops. Okay, so we got our print function there. We're gonna create our list. Okay, so this is indicating that it's a list and not a dynamic array or something. List for each. Okay. And then I could call print element on it. Okay, cool. And that's going to know as a higher order function to, well, for each element, I guess this is looking at the range here, 1, 2, 3. I wonder if I could just do like 1 dot. Actually, let's run this here. Okay, it works. I wonder, can I just do 1 dot print element? Let's see if that works here. Do I have, okay, I don't know if I have universal function call syntax in that same way where I can just put this together. But regardless, you know, I'm passing this function into for each, which knows what to do with it for list here. Okay, so pretty nice here, pretty clean. Let's see what else. You can assign a function to a variable. That's yep, super nice. So there we go. And again, they're using a anonymous function here and calling, you know, to uppercase and whatever the message is here. Okay, cool. So super cool stuff with anonymous functions here. Let's see. Uppercase. Let's go ahead and run this here. Apples, bananas, oranges is all in uppercase. So what did it do? It took this list. We've got maps. Okay, cool. Love seeing this kind of stuff. List, map. Here's the anonymous function to return the item in uppercase. And then convert this back to a list here. Okay, very cool. And then we got a range-based loop here. Okay, range-based for loop for var element in list, because that's what we have here. Print element. Let's see what I do here. Colon. Yeah, I do want to see. Okay, so if I gotta evaluate some code, I could put it in the I don't know what to exactly call this. I forget what it's called in Bash, but the $ with the brackets here, element here. Let's see if that works here. And it does. 1, 2, 3. Okay, cool. And this is supposed to be list.length or something. Okay, cool. So I've seen a few that built in some of the data structures and the how to say range-based for loop, and again, yeah, just the data structures here. Okay, let's gotta keep going through here. Closures. Okay, so they got function objects here, in the same way that C++ has functors, which is how you implement the lambdas. Return a function that adds 1 to the function's argument. Okay, cool. So I guess that's the way of yeah, basically creating a function object here. Okay. Tear-offs. When you refer to a function, method, or name destructor without parentheses, Dart creates a tear-off. This is a closure that takes the same parameters as the function and invokes the underlying function when you call it. If your code needs a closure that invokes a name function with the name parameters as the closure accepts, don't wrap the call in a lambda. Use a tear-off. Okay. So maybe, again, I don't know this terminology here, but let's see. We've got our character codes. I'm setting buffer to string buffer. Okay, good here. Function tear-off. Char codes dot for each print. Okay. Method tear-off. Char codes dot for each buffer dot write. Interesting. What's bad here? Okay. Char codes dot for each, and then doing the print here, and then the method lambda. Okay, these are bad because, let's see. When we refer to a function, method, or name constructor without parentheses, Dart creates a tear-off. So closure takes the same parameters as the function, invokes the underlying function when you call it. Okay, I mean, this seems pretty reasonable. I'm just passing in the function as a parameter here for this. I guess it's saying don't pass in the character codes here. Maybe it's like making a copy or something. I guess I'm just going to understand what exactly they mean by that. And then calling print versus just directly passing in print, which acts on the for each. Interesting. Okay. Quality, return values, generators. Okay, so this is a thing that folks love using, like all the time, generator functions. And you've got asynchronous and synchronous stuff here. Okay, so we're getting through quite a bit of the language here. That was just on functions here. Let's keep going down here. And again, where I am in the language here, I might want to skip around a little bit. Let's see, this is just on variables. On the Dart basics, I am going to skip to concurrency and patterns at some point here, because where are we? We're just getting the object-oriented stuff. Okay, we'll take a little bit of time here. I mean, this pretty much looks like other C-based languages here. I've got spacecraft, strings, a nullable type here, read-only, non-final property. Okay. Okay, so they've got properties in the language where it looks like you can explicitly set, like, if it's a getter or setter function. So you can access this launchier like a function, basically, and have a getter routine for it. But I guess I can't set it, so that's the thing to keep in mind. So I like that. That's reasonable. Again. Okay, read more about strings. String interpolation. That's a hot topic. Let's just search for string interpolation. Okay, this is where you're sort of embedding in the value or an expression here that you want to evaluate to get an object here. Okay, so the $sign is our escape sequence here, it looks like, to try to find some variable that's in the scope or otherwise available. And then if we want to evaluate something, we put it in the $sign in the curly braces to evaluate this expression. Okay, cool. It is very handy. It's a really cool tool to have. Let's see here. There's so much stuff here in this language. It's great. Built-in types. I guess we've seen lists, sets, mats, runes. Okay, so for characters, that's kind of a nice name for it. What else do we got here? Records, which I'm assuming are like structs or sort of a tuple thing. Let's see how they define them. Records are anonymous, immutable, aggregate type. Okay, so they are records. Okay, here's the syntax. I guess you could name their parameters. And you can just use them here to return multiple values. Okay, so that's pretty nice here. So it's basically, I don't want to call it a tuple. I don't want to call it a struct. I'm just going to call it a record because that's the Dart way. But maybe that's the right way to think about them, which is neat here. Okay, as far as the built-in collections, lists, sets, and maps. Yep, that'll do it here. And this answers our question. These are lists. Okay. Okay, but perhaps the most common collection in nearly every programming language is an array or order group of objects. In Dart, arrays are list objects. So most people just call them lists. That's confusing. Okay, so they are represented as arrays, contiguous pieces of memory. But we just call them list. Okay. I think that's the same. Is that true in Java as well? Even when you create, right, because you're creating array lists, which, you know, hopefully that name makes sense. Anyways, okay, so lists, some different things you can do on it. You can make them const and so on. Okay, cool. Sets. Okay, so we sort of get the idea, and these are generic, so you can put in the between the left and the right angled brackets there. You can put the type in here. Okay, so that's kind of nice here. Okay, so this is again, nothing too crazy here. Generics. Okay, so some cool stuff here. And again, it looks like it's smart enough to just figure out. Oh, let's see here. So this is just declaring this as a string and then adding to it. Okay. Type definitions. Okay, so C-like stuff here, which is nice. This is kind of nice here because, yeah, you know, I like using type stuffs for this type of thing. So if you're a C++ programmer or something, it looks like Dart is, you know, got a lot of the nice stuff that you'd otherwise want, which is pretty cool here. Meaning, like, you know, you want to be able to create, like, for a type here with the types that you want, and you can make these generic. So that's like the using syntax, but you could still, you know, make it a templated, which is kind of nice. Okay, so pretty cool here. Let's jump to patterns here. Let's see, as I'm going through the Dart basics, we've got enums. Again, I kind of skipped over classes, but, you know, they look like the same classes that we have here. Inheritance, mixins, a feature that I love here. Mixins are a way of using code in class hierarchies. Okay, so in D we have template mixins, which you can use here. Mixins are in D. There's string mixins, which is just mixing in a code, but this is like a basically template here where you can almost do like inheritance, multiple class hierarchies, as they mentioned here, using mixin. So if I have the piloted craft, you can add this piloted thing, which is basically going to build this class with one astronaut and be able to describe the crew here. So that's kind of a nice way to build up a class here. I think it's kind of neat here. Okay. Okay, async. Avoid, callback, HELL, and make your code much more readable by using async and await. Yeah. So again, this is going to be very familiar. This is pretty much taking the same thing that JavaScript has. I wonder which one was coming first in 2011 or so when we got these features, because that's kind of interesting. And then you have, okay, so maybe, and they're adopting this future object. So we have async, then your return is a future value. That's sort of the, in C++ we have promises and futures here. But yeah, this is the same idea. You're awaiting, and then your future is to get, I guess in 1 second. I wonder if this just returns a future void object, I guess, and then printing the message. Anyways, there's async await here, which is cool. That's good. Okay, so sorry, let's get to some other patterns here. Let's get to patterns here, because folks like pattern matching, which requires at least version 3.0. Okay, so again, a lot of languages are sort of, or at least I've observed, have all sort of said, hey, we need pattern matching, we need tuples or records or nullable types or these types of things. So they've come up with different solutions. So it is neat to see that, yeah, these are, features that are still coming to an evolving language, and the languages are still growing and so on. So let's see how to do patterns in a language like Dart here. And let's actually try to code one of these. Okay, so we've got switch here, constant pattern. Okay, 1 prints 1 here. Okay, so they just do this with switch statements. I mean, that's pretty nice. That's familiar. Just trying to see some different examples. Okay, so here's like a series of declarations. That's actually kind of nice, because then you can build up these aggregate types really easily, or these records, I guess. Variable assignment. Okay, so this wasn't the, maybe this isn't the pattern matching stuff that I'm thinking of here. Yeah, I mean, I guess it's just switching on an enum. Okay, and I'm assuming the compiler's gonna be smart enough to tell us, okay, yeah, this is like the switch on the color, and you get either your name of red, yellow, or blue, or you can return the false value if that pattern doesn't match. Okay, so it's got some pattern matching stuff here. That's great. Okay, when and why you might use patterns. This is really great documentation. I haven't said that yet. I mentioned it was pretty easy to get into Dart here, which has been great, right? We've been able to just do the terminal here. But the documentation for this language has been fantastic, so that's been great. Let's look at the last sort of concurrency stuff here. Let's see. Dart's runtime model is based on an event loop. Okay, so you'll have an event queue here, and I guess you could just queue up or concurrently have different events processing. Let's see here. Let's see if we could do. We looked at the asynchronous stuff with async and await here, and they've got futures. Okay. So I've already sort of looked at this. I want to see what sort of threads they have. Okay, they've got streams too. So give asynchronous code in the form of streams. Should provide values in the future and repeatedly over time. Okay, that's pretty cool. So if you're just reading in data or something from somewhere or another, you can stream it into some object. That's cool. Isolates, this is what I'm looking for, or isolates, however they pronounce it. Okay, multi-core CPU. Yeah, shared memory concurrency is like tricky with threads, I guess. So a lot of folks are saying, nope, all of your data is thread local. Your threads are basically separate things. So if they want to talk to each other, they can pass messages, but they can't access the same memory. And then you send and receive messages, right? Right, we don't want mutexes or locks or these types of things. So no shared data, okay? Unless, of course, you call into like a shared library or something. Okay, this is giving us an idea of the loop here. Okay, This is pretty nice. You know, if I was going to teach someone modern programming, you know, I like languages. Obviously, I use D and so on. Dart might not be a bad language, though, actually, looking through all this. I mean, I think we're just going to kind of wrap this up here, because I think we've looked at pretty much everything here. It's a reasonably sized language that's got a lot of the modern features that we'd like pattern matching, concurrency, nullables. You got some object-oriented programming, mix-ins, these types of features here. So it's quite a nice language, I would say. And they've got style guides, some stuff on the interop here. Oh, even Java and Kotlin interop. Interesting. Interesting. I mean, hold on. We got to click on some of these here. Hello world. Okay. So they got some repositories here. I'm guessing you can just import. Let's see. You set this up with some foreign function. Okay. Yeah. You just open up the dynamic library, look up the function with its signature, and then you can just call the function. Okay. So that's all pretty clean stuff here. Yeah, pretty cool. This is interesting. Java interop, JNI engine. Okay, cool. I guess there's a. Well, I mean, let's look at this Dart programming language again one more time here. There's a virtual machine here. Let's see on the platforms. Dart includes both a Dart VM with just-in-time compilation and ahead of time. Okay. So it's got the Dart. How are we getting to? I guess this is just with the JNI, so Java native interface. Okay. Okay, so we're just interacting with Java code. Okay, got it. Okay. I thought there was another like Java virtual machine or something connected. I mean, maybe there is, and again, with the JNI, you can interface with code from the both native code and Java code, which is kind of cool. Okay, cool. I mean, I think that gives us a lot of features here on Dart. I mean, so many that we're looking at here. Let's see what else we got here. Sunflower. Let's just run some of these projects and take a look here. See what's going on here. We didn't really get into the Flutter stuff, which could have been interesting. This is a very nice visualization. Very cool and creative. So again, what can I say about Dart as an overview here? I mean, let's just go ahead and take a look at the language here. It's very clean, modern language. You know, I think using it for app development and these types of things is very good. I'll emphasize that being able to build applications or your company or infrastructure in a language where you have the front end and the back end being the same code, I think that's a really nice thing. For code reusability, testing, ecosystem purposes, it's all very nice. It's got a lot of modern features. It seems like it has a nice theme to concurrency. We didn't see any. One of the unanswered questions was like major applications that were built in Dart. I'm sure there's tons of apps and stuff at Google or, you know, other companies here. You know, probably apps even on my phone already that I'm using that are using Dart. So I'd like to see them sell that a little bit more, because it'd be kind of cool just to see like a showcase or something. Like, are people writing games and so on? I know a lot of folks are using the Flutter API, so it'd be cool to see how they're using it with Dart, for instance. But overall, I'm very impressed with the language. I'd love to hear, you know, if you folks are using the Dart programming language, what you've thought about it, what platforms you're actually deploying to. Are you deploying to desktop, mobile, and web and having success with it? Because I think that's one of the unique things we've seen with Dart. We've seen it with a few other programming languages like Hax. That language was pretty interesting, and that could target like basically everything. So you can check that out on the series if you want as well. But anyways, folks, I hope you enjoyed this hour. I enjoyed looking at Dart. Again, having never looked at it. Again, we'll just go ahead and leave it on the screen here. I thought it was a nice, clean, modern programming language. It might even be a good language for someone to learn for the first time. Just because it seems pretty clean and clear, and there's built-in data structures, and it can target every sort of platform. So it's cool if you can build an app and show that to your friends. So, but at the same time, it seems like a really safe language, so it can scale up. But again, it's got the concurrency sort of model down for scaling up applications. So again, anyways, really impressed with the Dart language. Glad I looked at it. We saw some cool ideas like late and required and some other, you know, ideas that we've seen in other programming languages, but it was just also nice to see them and see how they were explained to give you control over the language. Anyways, folks, with that said, I hope you enjoyed this lesson. Hopefully you enjoyed looking at Dart with me, and I'll look forward to seeing you in yet another lesson later on. And feel free to comment on the discussion below if you've got comments, resources we should know about for Dart programmers for getting started, or just cool projects that someone should take a look at. I think that'd be really fun. All right, folks. Anyways, with that said, thank you as always for your time and attention, and I'll look forward to seeing you in the next one.